In this video, we'll look at distance applications. Distance problems involve the formula d equals r times t. The idea is that the distance that is traveled by an object is equivalent to its speed multiplied by the time it travels at that speed. So d equals r times t. This is the classic distance formula. Now, this distance formula can be rewritten to solve for time by dividing r on both sides. And in many cases, this is what we're more interested in. The time it takes an object to cover a certain distance is equal to the distance divided by the speed you go at. And this is what we're going to use in the examples in this video. Time equals distance over rate. But it is just the distance formula rewritten. Let's look at our first example. Town A and Town B are 36 miles apart. So I'll just kind of draw a picture here. Town A and Town B. 36 miles. A boat travels from Town A to Town B and then back. So the boat starts here and goes here, and it turns back around and comes back. Okay. Town B is downstream from Town A. So the current of a river decreases the boat speed when it is traveling to Town A, because when you go to Town A, you're going up river or against the current, and when you're going to Town B, the speed is going to be increased because you're going downriver with the current. So you're going downriver to get to Town B and then back upriver to go to Town A. So if you've ever been in a boat, a raft is actually a better way to kind of see this. A raft is going to go down with the current. You can't come back up unless you have some kind of motor on that raft to take you back up, but it's going to be harder to come back upriver because the current is fighting you. So that's the first thing to understand is what's going on. Turns out the speed of this current, let's say in this river, is 3 miles per hour. So that means the current is going to be fighting you when you're going upriver toward Town A at a rate of 3 miles per hour. It's going to be helping you when you go downriver at a rate of 3 miles per hour. Now what we know, the other piece of information we know is the whole trip takes 5 hours. 5 total hours. Total time, put that down, is 5 hours. When we think about this trip, there's 2 parts to that trip. There's the time going to B or downriver, and then there's the time going upriver back to Town A. And so those 2 times are going to be equal to 5 hours. So when we think about this formula, notice I said we were going to be using the distance formula, but with it solved for t, because the idea here is that if we can figure out the distance over the rate to go downriver plus the distance over the rate to go upriver, that should be equal to that 5 hours. So let's see if we can put all the information in. We want to find the speed of the boat in still water. So anything we're trying to find, that should be the variable. So let's let x be the speed of the boat in still water. Now remember, the current is going to affect the speed, and the speed of the current is 3 miles per hour. Now how that affects it is the speed of the current is going to increase the speed of the boat or decrease the speed of the boat. How we show that mathematically is with addition and subtraction. So when we're going upriver, the current is going to hinder you. When you go upriver, your speed is going to be decreased by 3 miles per hour. When you're going downriver, the speed is going to be increased. The current helps you by 3 miles per hour. Now, it is important how you show the subtraction when you're going against the current, that upriver speed. You must subtract the current from the boat, because if the boat has to be faster. If the boat were slower, then there's no way you could go upriver. The boat has to be faster, and you need a positive speed. Since the boat is faster, it has to be the boat minus the current for you to achieve any momentum. So with these definitions, let's go back to the equation here for time. The distance both ways is 36 miles. So 36 over the rate for going downriver was x plus 3, plus the time going up is again 36 for the distance over, we've now got a different speed because we're going upriver against the current, would be x minus 3. And that's equal to 5 hours. So our equation that we want to solve for looks like this. Now, we're going to clear fractions the first step. To clear fractions, we want to multiply by the LCD, which would be x plus 3 times x minus 3. These are different denominators, so you need to multiply by all of it. All right, kind of running out of room here. Let's see if I can squeeze it all in. So what I have is x plus 3 times x plus 3 all over 1 times 36 over x plus 3 plus x plus 3 times x minus 3, I made that mistake in my first one, has to be one of each sign, all over 1 times 36 over x minus 3. And on the other side, I'm going to have just the number 5 times that common denominator. Now, because I know the 5, nothing's going to cancel with that. Let me remind you of something. X plus 3 times x minus 3, that's conjugate. So when we square that out, we're going to get x squared minus 9. Not square, but FOIL it out. You'll get x squared minus 9. So I'm just going to write in, because I know I'm going to have to multiply that out by the 5, I'm going to write x squared minus 9 there instead of it in factored form, because I'm going to have to multiply it out anyway. And since I'm running out of room, that's one step I can do there. So the x plus 3's cancel in my first term. The x minus 3's cancel in my second term. So I'm going to have 36 times x plus 3. I'm going to distribute that while I'm here. 36 times 3 is going to be 108. And that's added to 36 times x plus 3. So that would be 36x plus 108. And that's equal to, distribute the 5x squared minus 45. Now, collecting like terms here, we have 36x plus 36x, which is 72x. The 108s basically add to 0. One's negative, one's positive. And that's equal to 5x squared minus 45. Get 0 on one side by moving the 72x over. 5x squared minus 72x minus 45. And then go ahead and factor. Now this is not an insignificant factorization. You may want to take your time and use the AC method, either the box method or the fraction method, so the shortcut method. I'm going to use trial and error. 5x and x, negative 45. If I use a 5 and a 9, which is my first choice, I don't get anywhere near the 72. So I'm going to try using another option for 45 is 15 times 3. If I put the 15 over here and make it negative, 5 times negative 15 is actually negative 75, which gets me really close to this negative 72. If I add the 3 here, negative 75 plus 3x, that's going to give me negative 72. So that's the one I want. So I have 5x plus 3 equals 0, or x minus 15 equals 0. Again, this factorization, if you need to do the AC method, just do it off to the side. It clutters it up if you put it on the page. Just do it on scratch paper. That way you're just putting into the equation your result when you factor. When we solve these individual factorizations set equal to 0, the one on the left, 5x plus 3 equals 0, gives me 5x equals negative 3, x equals negative 3/5. Now we can't have a negative speed, so this isn't going to make sense. And if you can kind of predict it, you know that's not going to be your answer. The other one gives us a nice positive speed of x equals 15. Now remember, what was x? X was the speed of the boat. So I'm running out of room. I can maybe squeeze it in here. The speed of the boat is 15 miles per hour. Let's write that in. And then we'll check. Speed of the boat is 15 miles per hour. To check this, I have a little bit of room up in the top of the slide. Let's go back to our original statement, which was that the time going up and back is 5 hours total. Well, remember, the distance is 36. So if I'm going to go 36 miles, downstream, when I go downstream, the speed of my boat is going to be increased by 3 miles per hour because the current is 3 miles per hour. So my boat speed, it goes from 15 miles per hour to 18 miles per hour. I'm going to add that to the time to go 36 miles, but now I'm going to go upstream. When I go upstream, my 15 miles per hour, my speed, is going to be reduced by the current. So 15 minus 3 is 12. So if we think about what these two fractions will give us, the time going downstream right here, 36 divided by 18 would be 2 hours, plus the time going upstream, 36 divided by 12 is 3 hours. When you look at 2 hours plus 3 hours, you get that total of 5 hours. So this answer does make sense with the distance formula.